Ranges are another important sequence type built into the Python language. They give us the ability to specify a sequence of integers that starts at some point, ends at some other point not inclusive of it, and is spaced out. The integers in the middle are spaced out at some interval. So we can imagine this kind of sequence. And remember, this is an example of an abstract data type where a sequence is a set of ordered items that are connected together in some way or collected as one in some way. Well, here we're thinking about a collection of integers that is a range. So if we imagine a number line and we go back to our elementary school education where we thought in terms of number lines and integers, we can imagine a range looks something like this, where at some point we're going to have a starting index, and that will be where our range begins, and it will be inclusive of this. So maybe our start is 0. And then the range will have some interval. And in this example, the interval might be 1. Notice where each one, we're indicating in this little representation, there's an extra point here that is inclusive. And so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then our endpoint, 10, this open circle is a convention that we use in number lines and math to say we're not inclusive of 10. So this would be a range that spans from 0 to 9 inclusive, or 0 to 10 exclusive. And we're only talking about exclusivity on the top bounds, okay? The starting point will always be inclusive in our use of ranges in Python. So the attributes of a range are the start of it, the stop of it, and what is the interval in between it. You could imagine a range of integers that was 0, 2, 4, 6, 8, and then not 10 because we end at 10, or intervals of 3, 4, and so on. Right? So a step is going to be how we describe our interval, and these are the 3 attributes that we'll model a range with. Ranges don't actually, like a list is actually made up of all of the items in it, and you think of a list as having, if we had a list that was equivalent to a range that was from 0 to 10, not inclusive, it would have had 10 elements in it from 0 to up to 9, right? Well, a range is a really interesting idea of a sequence because it really is modeling the idea of a range and only needs to keep track of what is the start, what is the stop, and what is the step. Those 3 attributes allow you to compute any index based on them, right? And so it's a sequence just like we've seen with the others, and we'll play with it in just a moment. We can construct a range as such. We use the range constructor, which is a built-in Python function that we can call. And you'll notice that the fully specified range constructor has 3 int arguments that are needed in order to call it because they correspond to the 3 parameters here: a start, a stop, and a step. I'm using some specific notation that you'll see commonly on, say, the Python website, where we're saying that this last parameter here is actually optional. If we don't specify a step parameter, it will by default be 1. So that would mean if we had a start and a stop of 0 and 10, we would get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You wouldn't get 10. 10 is exclusive, right? So let's try this out. Let's actually jump into a REPL and play around with the idea of a range in Python. So I'm going to bring up a REPL, and let's just say we do a range named 1 through 10. And it's a range type that is assigned a new range object that starts from 1 and goes up to 11 exclusive, right? So we've named our variable 1 through 10, so we should probably be inclusive of 10. I'm going to do both of my start index or my start attribute and my stop attribute one off. And in this case, I'm not going to use a step that's custom. We'll try that in a second. Right? So we've initialized this range, and if we were to look at it, 1 through 10, if we were writing a program and we printed it, we would see that it just gives us our constructor and tells us that, okay, our start is 1 and our stop is 11. And if we looked at, well, what is the first index? 1 through 10, index 0 is 1, right? That's the starting index. And if we looked at what is index 1, that's 2. What is index 3, 4? Oops, I skipped over 2. Index 2 is 3, and so on, right? If we tried index 10, we see that we've gone out of bounds because there's not actually an index 10. The highest index here would be 9, which is the value 10, right? Because we're using a range here that's so close to starting from 0 and stopping at 10, let's try one that's a little bit more interesting. And I'm just going to shorthand R for range and assign it a range that is, say, from 250 to 275, right? And now we ask what's R index 0. We see that it's 250, R index 1, 251, and so on, right? We also mentioned this idea of the step. So let's try reinitializing R to be a new range. And let's do 250, 275, and this third argument is going to be the step, or the interval between each subsequent item in the sequence, which is the range. And so now we say R index 0, it's still 250, but with a step of 5, when we ask what is the first, the element at index 1, notice it's 255 because we're stepping up each subsequent item in this range by 5. If we ask what is the length of the range R, there are 5 total elements between 250 and 275. And that makes sense because there's a difference of 25. 25 divided by 5 would give us 5, right? And so hopefully this is a pretty familiar and comfortable feeling concept. We can specify the idea of a range by giving a start and a stop. And our stop will be exclusive. And then we can optionally override a step. By default, it will be 1. We could use a negative step as well. And let's just bring this little demo home by saying, okay, well, what if we wanted to go from 100 to 0, not inclusive of 0, and step by -1? Well, we could look at R index 0, that's 100, R index 1, 99, and so on, right? So R index 10, 90, and you kind of get the point. So notice we can have negative steps as well if we wanted our range to have subsequent items that were integers counting down. The really cool thing about a range is that it's made up of these 3 attributes. So that means that its data representation under the hood is actually simpler than an equivalent list that would have those same items in it. So just like we've seen a list is made up of many items that are elements in it, a range is actually a kind of object that has attributes. And those 3 attributes are start, step, and stop. The way that we can access an attribute in an object, such as a range, is with object.attribute_name. So we'll go try this out in just a moment. So when we set up a range, what it would look like on our heap in memory, and we'll get some practice exploring range objects in memory as well in the coming lessons ahead. A range is assigned a range object that has a start attribute of 0, a stop attribute of 10, and a step of 2. It's going to be an object that's located on the heap that has those 3 attributes associated with it. Notice this doesn't have 5 elements in it, or if we had a range from 0 to 1,000, counting up by 1, there wouldn't be 1,000 elements in it. We only are ever going to need these 3 attributes for a range. And that's kind of neat. This gives you an example of why we call these things abstract data types, because notice we can represent the idea of a range much simpler than we can an arbitrary list that needs to keep track of all of its individual values. So let's go take a look at these attributes. So we say r.start, and that gave us the attribute 100, which was the starting point of this range. r.stop, that gives us 0, and r.step would tell us that we are stepping by -1. Just like with tuples and strings, ranges are immutable. We can't change these things. I can't say r.start is now 1,000, right? It tells us this is a read-only attribute. So if we wanted to make a new range that started from, say, 1,000 and went to 10,000 and counted up by 1, and I won't even specify the 1 because it's implicit, even though there's 9,000 numbers that would be represented in this range, under the hood in memory, Python is only needing to keep track of those 3. So this is a different kind of sequence, and it's a special kind of sequence that we'll see is very commonly handy when we're trying to count in specific ways. Often when we're working with indices, we're going to see that we combine the idea of ranges as well. So just as we've seen with lists and with tuples, a range is a sequence type. You can run off the end of a range and you will get an index error when you do. And so just some of the things that we talked about earlier in this video, the idea that we're abstracting the idea of a range into these 3 attributes. And we don't have to worry about this. This is kind of taken care of for us by Python. But it's worth knowing that when we set up a new range, Python isn't just creating a brand new giant list of all these numbers. So we could have a range from 0 to 100 million and it wouldn't be a problem, because underneath the hood, Python really only needs to keep track of start, stop, and step. And then when we use this subscription notation, it's able to compute, okay, well, if you started from 0 and you're stepping by 10 and you're asking for index 5, we can do a little bit of arithmetic to figure out what that exact integer would be. And that arithmetic is shown at the bottom of the slide here. We take, if you ask for some index, the way that you can compute the value of that index is with a little bit of arithmetic as shown. So that's the idea of a range, and we've now seen 4 different sequence types. As we move into this unit, we'll start to explore when do you use each kind and how do we think about them and separate them from one another. But to quickly review what we've seen so far, let's try and break this down. So our sequence types are strings and tuples and lists and ranges. With strings, we're storing items of characters, right? So each item in a string is a character. And we start with these and use strings first because textual data is really important to be able to work with. And since it's so easy to grab individual indices and do things like we did in encoding and decoding in Caesar Cipher, it gives us a chance to introduce sequences in a simple context. Tuples can have items of any type. But the key difference between a tuple and these other types is there's a fixed number, right? When we defined a tuple type, we said tuple and in square brackets, float, float, float for a tuple that could hold 3 float values. You can mix and match types in a tuple. It's less common, but it's possible. And you just have to be sure that when you go to construct a tuple that your expressions match up with the types that are specified in the type tuple. We tend to use aliases for tuples so that we can give more semantic meaning, right? So tuple float, 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 or tuple int, int, int is less meaningful than color. So we'll often, when we're working with tuples, try and alias the tuple to a more meaningful name. With lists, we're going to use lists of a single type. And this was fixed number of items, single type, and a dynamic number of items. Right? So we can have a list of integers and it can have as many integers as we want and we can hold in our memory. And ranges are int sequences. So a range is always going to produce an int. And under the hood, we know that it's only made up of the 3 values in order to compute some offset within a range, right? So there's one other item or one other attribute that I want to talk about with each of these, which is mutability. And I'm just going to write mutable. Oops, mutable. And this is the idea of, can you change it? After you construct a string, can we actually say change the string at index 3 without creating a new string? And the answer is no. Strings are immutable. The only way to get a new string from an existing string, or the only way to change a string, is to produce a new one. So when we concatenate 2 strings together, the input strings aren't changed, but we have a brand new string as a result of it. You can't change strings in Python, and this is true in many languages like it, Java, JavaScript, and so on. Tuples are also not mutable. After you construct a tuple, you can't change its items, you can't change its length, it's not dynamic. Ranges are not mutable, as we saw. If you want to have a different range or change some attribute of a range, you just need to make a new range, construct a new one with the different attributes that you want. Lists, however, are mutable, and this is their superpower, right? This is why we're going to wind up using lists to solve more problems more frequently than these other types. And with this mutability, we're going to have some new concerns as well as we start looking at how we have to think about these things in our environment diagrams. The fact that we can change them means that we need to be careful in how we access them. And we're going to learn some new rules for environment diagrams that apply to lists and other mutable types that we'll learn later in the semester. But with that mutability comes a great deal of flexibility. So these are our sequence types. The key idea of a sequence is it's an ordered set of indexed values called items that are zero indexed, so 0, 1, 2, 3, 4. And here we see that there are that abstract data type can be manifested in these 4 different ways. And we can have more different types of sequences as well. And we'll see some additional ones later in the course.